Hello everyone. In today's lecture, we are going to discuss the shapes of S, P and D orbitals. Okay. Before starting this, we have to understand what is meant by the orbitals, and then we go for these shapes of S, P and D orbitals. Okay. Now, Bohr, according to Bohr, okay, electron moves around a nucleus in a circular sharp path. It can be denoted as here. Suppose this is a nucleus, this is the circular sharp path, and here the electron is located with a negative charge. Okay. Now, according to Bohr, what is this? That is, electron moves around this nucleus in a sharp circular path, and that path is called as stationary shells, and that stationary shells are represented by the letters capital K, L, M, N and so on. That is, K shell denotes the first shell, second shell, third shell and fourth shell. The number of electrons present in that shell is calculated from the formula, that is equal to 2 into n square. Here K is equal to n is equal to 1, n is equal to 2, for M n is equal to 3. How many electrons can accommodate in first shell? It is according to 1 square is equal to 2. Therefore K shell can accommodate 2 electrons. L shell can accommodate how many electrons? 8 electrons. M shell accommodate is equal to how many electrons? 18 electrons and so on. Okay. Now, after this, one observation is made, that is, an electron behaves as a wave as well as a particle. Already we have seen in this deriving the de Broglie's equation. Okay, that is, electron behaves as a wave, as a particle. So it is difficult to locate the electron in a circular orbit. That is, there is a question, that is to locate their electron in a circular orbit around the nucleus. But in 1926, the new scientist known as Schrödinger developed a set of equations in which gives the energy and probability of finding the electron in a particular area where it surrounds the nucleus. Such particular area are called as orbital. Such particular area are called as orbitals, which are nothing but the three-dimensional structure. Okay, that is along to x, y and z axis. And according to this situation, the definition of orbital is that, see here, orbital is defined as, it is a circular path, it is an electronic path or electron path, or the probability of an electron of finding an electron is maximum is known as the orbital. Now we come to our point, that is shapes of orbitals. See here. Here, shapes of orbitals represent the region in space where electron belongs with its energy levels and its probability of finding the electron. Okay, and these shapes of orbitals in which region in space an electron belongs to its energy levels, they are based on orbital angular momentum and orbital quantum number. Which can be designated by using the relation is that is orbital angular momentum is equal to what? Square root of L into L plus 1 into h upon 2 pi. Okay, up to this we have to derive here, that is shapes of orbital represents the region in space where the electron can belongs to its energy levels, where the electron can easily found, and which can be related with orbital angular momentum and the orbital quantum number or azimuthal quantum number, which can be denoted by the letter small l, in which the orbital angular momentum is equal to square root of L into L plus 1 into h upon 2 pi, where h stands for which? That is Planck's constant, is equal to 6.67 into 10 raised to minus 13. Okay, now we come to our point, that is known as after this we have to come here the shapes of s orbital first. See here, shapes of s orbital. First of all, I will draw the diagram one by one. You can draw the diagram here according to the three-dimensional structure. Y, Z, X. Okay. This is the diagrammatic representation of an s orbital. When according to the orbital quantum number, that is L is equal to 0, in orbital quantum number L is equal to 0, at that time it denotes the s orbital. As L is equal to 0, there is magnetic quantum number m is equal to 0. Therefore, resultant orbital has full of symmetry in which surrounds the nucleus. That is, as the nucleus is positive charge, therefore finding of an electron around this nucleus is the same in all the directions. Which directions? X direction, Y direction and Z directions. These are the nodal planes of an electron in which electron can move. Therefore, as L is equal to 0, M is equal to 0, therefore probability of finding an electron is maximum towards all the sides. That is, the probability of finding an electron that is equal to a symmetrical one. Therefore, there is only one s and one s orbital. Okay, that is in K shell, that is one s orbital. In L shell, one s or 2s orbital. In M shell, 3s orbital. Therefore, there is a specificity of s orbital is equal to 1. Okay, the s orbital stands for the stands for the spherical one. As the circular orbits around this nucleus are called as stationary orbits, which are denoted by the letters capital L, L, K, L, M and N. Therefore, according to the principal quantum number, that is N is equal to 1, at that time the number of electrons in a particular shells is equal to the specific 1. Okay, as the value of this N, that is the principal quantum number, is increases, the energies of the suborbital, that is known as s orbital, is also increases. That is, as N is increases, there is a size of s orbital along with the energies also increases. Okay, thus this is s orbital. In K shell, only a 1s orbital. In L shell, there is a 2s, only one orbital. In M shell, there is a 3s orbital 1. Okay, as the principal quantum number is increases, there is increase in size of the s orbital. And as the electron is, that is here, electron is located here in this shell also. As the distance between the nucleus and the electron is increases, there is the denotion of attraction between the positively charged nucleus and electrons is also a decreases. As this distance is increases, the attraction between positive charged nucleus and negative charged electron is also decreases. Okay, now we go for the second orbit, that is known as the p orbit. Okay, now see here, p orbit. Okay, what is the previous statement of ours? That is L is equal to 0, at that time M is also equal to 0. When L is equal to 1, what happens? Here, when L is equal to 1, M is equal to what? According to the formula, M is equal to what? That is 2L plus 1. Therefore, putting the value L is equal to 1 here, that is 2 into 1 plus 1. Therefore, M is equal to value 3. Now, which are the 3 coordinates or 3 values of M? That is equal to, therefore, -1, 0 and +1. These are the values according to our previously learned quantum numbers, which are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. These are the values for M. These 3 values of M denotes the p orbitals of a 3 coordinate axis. Which are the 3 coordinate axes? First is px, second one is py, third one is pz. Which are the orbitals and how they are located in along a axis? Here one point should be noted that as p orbital comprises of the three suborbitals according to the coordinate axis, these three orbitals possess same kind of energy and shape. Therefore, these orbitals are also known as degenerate p orbitals. Degenerate p orbitals. Okay. Now, I will draw here the shapes of px, py and pz orbitals. See here, px, py and pz orbitals. These are the coordinates. Okay. This is x, this is y, and this is j. Y, this is j. X, y, and j. Okay. Here, p orbital of px. See here. Now these are the diagrams of px, py and pz orbital. According to what? Which value? That is L is equal to 1, M is equal to 3 values -1, 0 and +1. Okay. This is p orbitals. P orbitals have two lobes which are located around this positively charged nucleus, and these lobes contains the opposite signs with each other. This is negative sign, this is positive sign. This is negative sign, this is positive. This is negative sign, this is positive sign. Each lobe inclines with a coordinate axis such as x, y and z. Okay. Here x, y and z and so on. These p orbitals have the two lobes which are located surrounding the nucleus and which are inclined with the coordinate axis with a 90 degrees. With a 90 degrees. Now, the probability of finding the electron in these p orbitals of px, py and pz, here these orbitals is same because here px, py and pz orbitals are degenerate 1. The short form of p as derived from the spectroscopy study as principal. Okay, and as the value of principal quantum number n is equal to 1, 2 is increases, the energies of p orbitals is also goes on increases. Also, one more specification is that except the K shell, all the shells possess the p orbitals, because L shell stands for only one s or only s orbital. S stands for only s orbital along with a p orbital. M shell stands for along with a d orbitals and so on. Therefore, except K shell, after K shell, all the shells present in between the p orbital. Okay. Thus, these are the shapes of the p orbitals. Now we come to the d orbitals. Spectroscopic studies shows that the d orbitals are totally is equal to 5 and the meaning of d is diffused. In d orbitals there are only 2 types. However, the total number of orbitals is equal to 5. How they are 5? We are going to see here. D orbitals. As L is equal to 2, M is equal to 2L plus 1. What is the value? 2 into 2 plus 1, that is equal to 5. That is M is equal to which value that is equal to? Minus 2, minus 1, 0, okay. Then plus 1 and then here plus 2, okay. Now, as the values of M is equal to 5, therefore there is presence of how many d orbitals? That is equal to 5 d orbitals. The shapes of d orbitals are come across according to the symmetry of d orbitals. Actually, all the d orbitals are also degenerate one. But in d orbitals, there are 2 types. Which are the 2 types? According to the situation of the orbitals along the axis and between the axis. First one is along the axis and between the axis. Total number of how many orbitals? 5. Along the axis are 2 orbitals and between the axis are 3 orbitals. Okay. Which are the 2 orbitals? These orbitals are commonly known as Eg orbitals. They are known as the x square minus y square, and second one is d z square. And here, which are the 3 d orbitals? That is equal to dxy, dyz and dxz orbitals. Got it? Now we will see about the diagrammatic representation of these orbitals one by one. See here. In drawing the 3 orbitals, I will draw only the 2 axes. First of all, see here. First is between the axes, that is called as T2G orbitals. See here. X, Y, Z, X, Z. Okay. Now we will draw the diagram as here. See here. Like this fashion. In drawing the lobes, you can take precautions as they are of equal sides. Okay, this is dxy, this is dyz, this is dxz. The lobes having alternative positive and negative signs. Okay. Therefore, these are the 3 orbitals. Remaining 2 orbitals are here. That is the along the axis, which are EG orbitals. I am writing here that along the axis y, x, and last one is about the z orbitals. Z square orbital, and here d x square minus y square. Okay, now this is the diagrammatic representation of d orbitals. D means, according to spectroscopic studies, D means diffused. According to the azimuthal quantum number L, that is L is equal to 2, how many orbitals are here? Therefore it is 5 orbitals. These 5 orbitals are divided into 2 sets, T2g orbitals and here EG orbitals. In T2g orbitals, 3 kinds of orbitals are here. dxy first is dyz, yz and dxz. These 3 orbitals are degenerate one. That is, these orbitals are lying between the axes and they incline with the coordinate axis up to a 45 degrees. 45 degrees. Each lobes of d orbitals are alternative positive and negative signs. Okay. As the value of principal quantum number is increases, the energy of orbitals along with the size is also increases from the 3p after 3 orbitals. That is 3s orbitals. In between the second criteria, that is known as the EG orbitals. These orbitals are located along the axis. As they are located along the axis, they have much energy than the between the axis orbitals. Okay, noted as like this here. This is x square minus y square. These have alternative positive and negative lobes situated along the coordinate axis, but in dz square both the lobes have the positive sign. This system you have to must remember. And here the circle draws here at the center of the nucleus. Here the negative charge is present. Okay, actually nucleus is a positive charge, but here the electron cloud is here, that is of a negatively charged. Okay, therefore in dz square orbital both the lobes have a positive sign, that is also located along the axis. Thus, according to these types, there is a development of the blocks in a periodic table. These are known as S, P, D and also F orbitals. When L is equal to how much quantity? Here L is equal to 2. When L is equal to 3, M is equal to what? 2 plus 2L plus 1. That is 2 into 3 plus 1 is equal to 7. Therefore, for F orbitals, how many orbitals are here? That is 7 orbitals are here according to the spectroscopic study. In this way, we have studied in this lecture about the shapes of the S, P and D orbitals. Okay. I hope that all of you like my video. Please share, subscribe the videos. Thank you.